Okay, the next problem states 49 x to the 8th y to the 4th minus 16 z to the 10th. Step by step, checklist. One term, two terms, I'm good. Next on the checklist, is it a difference? Sure is. Happy about that. Next on the checklist, is this a perfect square? 49 looks good. X to the 8th and y to the 4th look good as well. Here's how, of course we know about numerical perfect squares, but to make sure that your variables are perfect squares, they have to be even because you have to be able to take half of them. So if you had an x to the 9th, it would not be a perfect square. But this one is. Check the last one. 16 is good. Z to the 10th, because the 10 is even, that's good as well. So we're good with perfect squares. Check, check, check. We're good to go. Now let's do the steps. First step. Find the square root of 49 x to the 8th, y to the 4th. Square root of 49 is going to be 7. Square root of x to the 8th is going to be x to the 4th. Square root of y to the 4th is going to be y squared. So although it had two variables here, the process is still the same. Just to show you, I'm going to write down both terms. Perfect square means that you can multiply two exact terms that are exactly the same. Okay, I'm only going to take one of them because that's the perfect square, the square root. Okay. Square root of 16 is going to be 4. Square root of z to the 10th is going to be z to the 5th. Okay, so step 1 says find the square root of each term. What I have circled is the square root for each term. Next, write down the skeleton. Skeleton, parentheses, parentheses, one with a plus, one with a minus. And what do you fill them in with? You fill them in with your square roots. 7x to the 4th y squared minus 4z to the 5th times 7x to the 4th y squared minus 4z to the 5th. Answer. This difference of squares factors into a product of two binomials. All right, the last example. Okay, my paper looks kind of smudged here, but that's okay. On the last example, I give you a hint, and I state that you need to find the GCF first. So what we are doing is we are actually combining two methods at one time. Okay? GCF is the greatest common factor. If we look at both of these terms, they both have something in common. Actually, they have two somethings in common. The GCF for 121 and 11 is actually going to be 11. The GCF of x to the 4th and x squared is actually going to be an x squared. So 11x squared is my GCF. Now, remembering what we did when we factored with GCF, you take out the GCF and then you write what's left over. All right, what's left over? 121 divided by 11 is actually going to be 11. And then x to the 4th divided by x squared is going to be x squared. And then 11x squared divided by 11x squared is going to be 1. And it is a subtraction. Okay. Now, after you divide out your GCF, you need to check this term. So we need to check this term to see if it is a difference of squares now, because it is two terms. It's like lathering, rinsing, and repeating when you're washing your hair. You factor as far as you can with one method, and then you change methods to see if you can break it down any more. Okay? In this case, we need to go through our process again. Do we have a binomial? We do. Do we have a difference? We do. Do we have two perfect squares? Well, 1 is a perfect square, but be careful. 11 is not a perfect square. So that's the part that we cannot deal with. So we have a final product of 11x squared times 11x squared minus 1. This cannot be factored with difference of squares. We pulled out a GCF. It almost looks like a difference of squares, but because we have an 11 here, 11 is not a perfect square. Okay guys, one last problem. This one's not on your sheet, but because the last one didn't work out like I wanted it to with the GCF and the difference of squares, I have one here that will work with a GCF and a difference of squares. So let's do this one. Flip your graphical organizer on the back and write this one on the back, please. Alright, the problem is 48xy to the 7th minus 12xy. Okay, I gave you a hint and told you that we need to factor out a GCF. Okay, look at each term. 48 and 12. Looking at 48 and 12, I see that I can take out a 12. Rewrite this 12 from each coefficient. I can also take out an x and also a single y. Now when you're doing GCFs, you write the GCF and then you write what's left over. There's two blanks here because there's two items to begin with. So 48 divided by 12 is going to be 4. X divided by x is going to be 1. Y to the 7th divided by y is going to be y to the 6th. Then we have 12 divided by 12, which is 1. X divided by x is 1, and y divided by y is 1. So we have 4y to the 6th minus 1. Now, we need to check to see if this product, the second part of the product, is a difference of squares. So let's go through our checklist. Our checklist states, okay, do we have two terms? We do have two terms. Check it off. Do we have a difference? We sure do. Look at the first term. Look at the second term. Is each term a perfect square? 4 looks good, y to the 6th looks good, and 1 looks good. So we're good. So we do have a difference of squares. Okay? Now, the steps for figuring out the product that you get from a difference of squares is that you first must break down each term into its square root. Square root of 4 is 2. Square root of y to the 6th is y to the 3rd. Okay? Remember, a perfect square has the same terms. Same terms, it could be a product, so taking the square root means that you just pick one of those terms. 1 is going to break into 1 times 1. So the square root of this guy is going to be 2y to the 3rd. Square root of 1 is going to be 1. Then we're going to write our skeleton. 1 with a plus, 1 with a minus. Put the first square root here, second square root here, first square root here, second square root here. Now, remember we started with this guy. Now we broke it down by pulling out a GCF first, so the GCF still needs to go in the front of our answer. So we broke it down into these two pieces, and then we broke down the second piece into two additional pieces. Okay? That is what factoring is. You break it down into pieces, and then you check the pieces to see if they can be broken down any further. Okay? Is this a difference of squares? Let's look at it real quick. Two terms, good. Not a difference. Not a difference, so you can't go any further there. So we're done with that part. We're done with the first part because it's the GCF. We're done with the second part because it's not a difference. Look at the third part. Two terms. It is a difference. Let's check to see if they're perfect squares. 2 is not a perfect square. So guess what? Since it's not a perfect square, we're done with that one as well. This is the final answer. Alright, hopefully that was a good video for you, and I will see you guys tomorrow in class. Thanks.